Hello students, last class I explained you about the working of analog input module or analog to digital converter. So based on the circuit, based on the hardware available inside the analog input module, so we classified that ADC into 5 categories. One is counter type, parallel ADC, SAR, sigma delta and dual slope integrated type ADC. So let us see one by one. So what is the basic building block of ADC? The comparator, it is the heart of your ADC. The comparator, what is comparator? It compares two values. It compares the two voltage. So generally your operational amplifier acting as the comparator. Your op amp has non-inverting terminal and inverting terminal. The voltage, the potential is connected in the positive terminal is known as V1 and we have connected V2 voltage. The V2 voltage is connected to negative terminal and the third terminal is the output. So your operational amplifier or IC741 is acting as a comparator. It compares the two values, it compares the two signals V1 and V2 and it produces the output. So a comparator is a device that compares two voltages or currents and outputs the digital signal indicating which is larger. It means suppose if V0 your output value equal to 1, when it is 1, if V1 greater than V2, your plus side voltage, positive terminal voltage is greater than V2 negative terminal voltage. V1 greater than V2 means your Vout will be 1. If V1 less than V2 means your Vout will be 0. So it compares V1 and V2, that's why it produces the output value. That's why it is known as comparator. It is a basic building block of ADC. So you must understand it very well. For example, V1 is 10 volt and V2 equal to 7 volt. So 10 is greater than 7. That is plus terminal potential is 10 volt, minus terminal potential is 7 volt. Ultimately 10 minus 7 you will get positive value. So it will become 1. So your output value will become 1, logic 1. Here V1 greater than V2. V1 5 volt, V2 7 volt. Then what will be the output? It will become negative. So it will be 0 since V1 less than V2. So it is an example to understand the operation of comparator. So let us discuss about flash type ADC. So before that I would like to introduce about the series circuit. So here I have connected two resistors in series, 10 ohm resistors are connected in series. Now I am applying 12 volt. Then what will be the voltage drop across each 10 ohm resistor? It will be equally divided because the resistance are equal, 6 volt and 6 volt. Suppose if I connect 3 10 ohm resistors in series and if I apply 12 volt, what will be the voltage drop across it? It will become, the voltage will be equally divided, 4 volt, 4 volt and 4 volt. Similarly, if I have 4 resistors, then the voltage drop will be 3, 3, 3, 3. If you add all 3, you will get 12. 12 equal to 12. Potential rise equal to potential drop. That is KVL. Suppose it is a horizontal view. Suppose if I arrange all the resistors in a vertical view, all are 10 ohm resistor, I am applying 12 volt. Then this 12 volt will be equally divided in as 3 volt, 3 volt, 3 volt. So each resistor experiences a 3 volt voltage drop. And this green color shows that it is with respect to earth or negative zero potential. So if I measure the voltage across this resistor, the voltage will be 3 volt, and with respect to ground and the second resistor, so here it is 3 volt and 3 volt. So 3 plus 3 you will get 6 volt. If I measure across this resistor, then the voltage will be 9 volt, and if I across this last resistor, the voltage will be 12 volt. So with respect to ground, it is 12 volt. So you have to understand the potential or the voltage divided rule. If the resistance are equal, then the voltage drop across the resistor also equal. So we will discuss about 2-bit flash type ADC in our next lecture. Thank you.